We now move to the next session, Smart Ship Technology Trends, Market Outlook and Opportunities, wherein we'll see presentations by Mr. T.S. Girish, Area Manager, India, Sri Lanka, Bangladesh and Thailand, Maritime DNVGL, Dr. Abdul Rahim, Corporate Officer and Regional Manager, Class NK, Mr. Akshay Jain, Founder and CEO, Vedam Design, and the session would be convened by Mr. Santosh Patil, AVP Business Development, Indian Register of Shipping. I would like to invite Mr. Girish to present. Mr. Girish is a marine engineer. He sailed with the Great Eastern Shipping for 8 years and then joined DNV. Mr. Girish has been with DNV for 19 years in various positions in India and Middle East. He is presently the area manager looking after DNV's maritime operations in Indian subcontinent and Thailand. Over to you, Mr. Girish.
Thank you. Can you hear me? Am I audible? And I hope my video is clear as well.
Yes, yes, sir.
Okay, I will share my screen now. So is the screen visible now?
Yes.
I will make it into. Okay, I hope it's in the right format. I hope it is in presentation mode.
Yes.
It's not.
Yeah.
It's not.
It's not.
No, just go to the right side to the full screen. Just 2 slots on the right.
In the right. Huh? You are not seeing it on presentation mode. Huh? Let's see. Okay, is it okay now?
Yes, it's okay now.
Now, yes.
Okay. Yeah, a very good afternoon, everyone. So I, of course, my thanks to the organizers of INMEX for giving me the opportunity to present in this webinar. So before I start the presentation, I'd just like to give a very brief background about DNV. Now, we were established in 1864, and we are, majorly working in 4 business verticals: maritime, energy systems, management system certification, and digital solutions. And we are an independent foundation with no investors. So we actually invest close to 5% of our annual revenue into research and development, which sort of translates to approximately $150 million every year. So now coming to the presentation, what I'm going to touch upon. What I would like to mention is what I'm going to cover today is, of course, digitalization and smart shipping, and of course, how this is going to play a role in the coming years, not only towards optimizing costs for shipping and ship owners and various stakeholders, but it's also going to play a major role as far as decarbonization is concerned. So what we are seeing is, we are seeing that quite major tectonic shifts are transforming not only shipping, but in our daily lives as well. Of course, COVID has happened, and that has, of course, shook up, every aspect of our lives. So markets, of course, are quite unpredictable. We saw one of the major contractions as far as GDP is concerned. Ship-borne trade also reduced last year by almost 3.5%. But having said that, I will say that I think despite all the unpredictabilities, at least majorly all shipping segments are doing quite well. I have been telling all my years, over the last 12 years since the global financial crisis, that we will never see the super cycle between 2005 to 2008. I would like to say that I'm happy to say that I've been proven wrong, at least as far as the containers and the bulker market. I think we have seen some of the best prices or charter rates the last possibly 1 year or so. Well, but of course, COVID, the pandemic is unpredictable. We still don't know how things are going to shape up as we go forward. Now, adding on to that, we are also shipping is under tremendous amount of stress from all stakeholders towards decarbonizing as soon as possible. IMO is being challenged by local regional players like you towards coming up with much more concrete measures towards decarbonization. Of course, we are seeing that over the last few years, digitalization and various aspects, or what we call as the fourth industrial revolution, has transformed in almost every aspect of our lives. I would also like to highlight that COVID, in a way, has also turbocharged the embrace of digitalization, not only shipping, but every aspect of industries. So now jumping into, again, as I mentioned, digitalization is going to play a major role as far as decarbonization is concerned. It's not only we are not only talking about cost efficiencies out here. We will see immediately that at least the low-hanging fruits as far as reduction of carbon footprint as far as shipping is concerned is going to come from digitalization. So, if I turn the clock back possibly around 20 years or 25 years back, I didn't own a mobile phone. I never felt the necessity to own a mobile phone. Now today, if I step out of my house, I will feel lost, or if my mobile phone gets completely discharged, I feel that I don't know what to do. And I can say today, our smartphones are possibly pretty much equivalent to a supercomputer that existed in the 80s. So all this has happened because we moved from, let's say, I still recollect in the 90s, it used to be a small dial-up line that I would be using towards connecting to the internet, and it would give possibly around 256 kbps speed. Now we are talking about, even a 25 Mbps or a 50 Mbps speed is not sufficient for us. So we have moved from 2G to 3G to 4G, and we are talking about 5G, and that's going to majorly shape how things are going to work and how things are going to shape up in the future. So people ask me, well, are we going to see autonomous vessels? Absolutely, without any sort of any manual intervention, within the next 5 years. Well, I say I don't know, but I do perceive that as we go forward, as we see that these connectivities improve even better, we will see that possibly in the next 1 decade or so, at least short sea shipping, we are likely to see that they may become largely autonomous with not much interventions or manual interventions. Of course, there are still quite a lot of regulatory aspects that are required to be sorted out. Of course, as I mentioned, we already have, in Norway, we have a company named Yara Birkeland who have their first vessel in trials. It's already operational. It's a 120 TEU container vessel. I think in the last session, we also noted Cochin Shipyard is building a couple of these autonomous vessels also for a Norwegian owner. We are also hearing news about various other parts of the world where these autonomous vessels are in various stages of trials. Of course, at this point, we cannot call them fully autonomous. Maybe there are people on board who are doing nothing. It's all remotely controlled. but as we move forward, I think as the, what shall I say, as the data analytics and machine learning makes the softwares even more intelligent, we will see that these become truly autonomous without any manual intervention. And then, of course, as I again started off my presentation, the connectivity, what we are seeing is helping us to control things, centralize things, and make things in a much more efficient manner. We are already seeing many trains, even in India, or many of the metros are driverless and are operated from a single control station. I know for a fact in Europe, a company named Avinor has centralized the control towers, removed all the local control towers in approximately 32 airports and made it all centralized from one single central control station. And similarly, we are seeing process plants, 20 odd process plants have been, the controls and operations have been centralized from a single control station. We are also seeing, production platforms now unmanned in the North Sea and being controlled from a control station. So this is what we are moving towards. And so we have to sort of embrace and shift our thinking on how we develop our competencies and how we start thinking how digitalization is going to transform. So then, of course, I know that the speakers after me are going to talk about digital twins and all that stuff. Again, it all boils down to live data that is coming from the vessel. It all has come down to the amount of connectivity that we have, and that's resulting in it's possible for what shall I say, control centers remotely to monitor what is happening on a main engine or a purifier or an auxiliary engine or a boiler, and they are able to support in an effective manner. They are able to troubleshoot, support the crew on what is to be done. In fact, we are seeing that we are moving away from, what shall I say, previously what used to be called as planned maintenance to a condition-based maintenance to a predictive maintenance. We are able to use these digital twins that we are making to effectively analyze the data that is coming from the various sensors on board the vessel and identify anomalies and say that, okay, this equipment is likely to fail possibly in the next 200 hours. There was a joint industry project that DNV was participating with a drilling company where they were able to get that data and use that data to predict. And we found that we could advise the rig owner that it's likely that this equipment is going to fail in possibly in another 3 months' time. And they allowed it to fail, and it did fail. So that's, I would say that, yes, we are looking at, what shall I say, major cost efficiencies kicking in, and also a more safer way of operations. So these are what we are looking and what's sort of the future that we are looking at. Then, of course, 3D printing and additive manufacturing is also going to play a major role. Of course, we at this point see that maritime and oil and gas industries just about constitute just around 5%. But I do perceive that as this, takes on in a big way, we will see that the amount of dead capital that is there in the form of spares on board will be reduced. We will see that when a vessel goes to a dry dock and sees that there is a problem with their tail shaft or a propeller, now we will see that the vessel is stuck in the yard because they can't get the propeller within 3 months or so, because that's sort of the lead time that is required to manufacture the propeller. But with this 3D printing, I think all these sort of downtimes gets reduced dramatically. But more importantly, we are going to see major trade dynamic shifts that's going to result in a much larger reduction in carbon footprint. The way the world trade is going to happen is going to majorly change with a greater uptake as far as 3D printing is concerned. And then, of course, when we are talking about classification per se, 4 years back, if somebody had come and told me that, can you do a inverter survey or machinery survey from remote sitting in your office, I would have said no. It's not that the technology was not there, it was very much there, but I would say that we were reluctant to use the technology. But that's where I think COVID played a major role. I can say that as far as DNV is concerned, and I know for a fact that other classification societies also, with support from flag states, we have in the last possibly 2 years done major surveys like flag chain surveys, which could have been we could never have thought of from doing by remote. We have DNV, I can say, has done possibly 100,000 plus remote surveys in just 2 years. So again, major things changing, which I would have expected to have changed in possibly in 5 years' time. It's sort of accelerated because of the pandemic. Then, of course, I think drones are nothing new. But we have also tested drones to, drones to be used for taking thickness measurements. And going forward, I also see that possibly thickness measurements will become redundant. Just a laser scan of a tank and then uploading it to the digital twin, we can immediately live, we can see what is the condition of the tank, what kind of coating or structural breakdown that happens. So quite a lot of things that are, that are likely to happen, and the way we work, with all these digitalization that's expected to come in. But having said that, I also would like to highlight that with all these connectivities, there are also various other risks that are emerging. We are seeing that, hacking from remote, and we have seen a case where Jacob Rig, we had a major safety failure. We are seeing terminal operations that got disrupted. Billions of dollars were wasted because hackers were able to completely disrupt the operations and injected in malwares, etc. So apart from that, we are hearing about stories where ship staff are unable to start a main engine just because it was a minor software glitch. 25-30 years back, when I used to say we just could go down to the emergency maneuvering stand and we could start the engine, but now that's not possible for 2 or 3 days. At mid-sea, the crew unable to do anything because they don't know what to do because it's a software glitch. Then we are talking about new fuels that are kicking in. We're talking about methanol, LNG, ammonia, hydrogen. All these are adding on to uncertainties. And what we perceive as far as DNV is concerned is there was a white paper that was launched last year. We see that there is a major emerging safety gap, and which has to be addressed. And if it is not managed properly, it's going to delay on how we progress with digitalization and decarbonization. So this is a major aspect that has to be addressed. And when we look at it, what we perceive is that stakeholders are working in silos. There is the focus is not on overall system performance. There's no sharing of knowledge. There is no experience exchange as far as safety aspects are concerned, which I think are going to play a major role as far as digitalization is concerned and technology embrace is concerned. Then, of course, we are talking about crew, which is a very, or human element, which is a major role. I think in the last session, Mr. Rishi was addressing that point. Are we addressing the competence gaps? Are the training that's required for the people who are going to operate these systems? Are the organizations geared up for how they are going to embrace all these aspects? Is the regulatory aspects, what shall I say, geared up to, or is it transforming itself and ensuring that the pace at which the transformation is happening? Are we addressing all the regulatory aspects? These are things that we believe have to be addressed in the next few years. So just summing up, yes, a digital transformation is going to play a major role, and we are not talking about just cost efficiencies out here. It's also going to play a major role as far as decarbonization is concerned and safer operations. But having said that, we perceive that there is a safety gap that's emerging that has to be closed to ensure that that these transformations are embraced in a safe manner. So that's it from my end. I hope I managed to keep myself to the time that Padma mentioned to me. Thank you, and I'm open for questions or.
We'll take the questions later, Mr. Girish. Thank you very much for that in-depth presentation.
Thank you.
To the next presentation by Mr. Akshay Jain. Mr. Akshay Jain is founder and CEO of Vedam Design. Vedam is a 150+ strong naval architectural firm with a mission to provide innovative and customized design, technical services, and technological solutions to maritime industry for greener environment. It brings a modern approach to engineering challenges, and for the last 15 years has successfully provided innovative solutions for 1,000+ projects covering vessel conversions, retrofits, new design, site inspections, and supervisions. Vedam has been working extensively on decarbonization for existing ships and for new ships via the development of LNG and future vessels. The company also provides various AR, VR technological solutions for making ships more connected and ship informed, more easily accessible to all the stakeholders for faster and better decision making, leading to cost saving and efficient operations. Akshay Jain is a naval architect from IIT Madras, India, with an executive program from Harvard Business School. He started his career working in new building and dry docking department of Omi Shipping and has worked in South Korea and several shipyards worldwide. Over to you, Mr. Akshay Jain.
Thanks, Padma. Just confirm me when you can see the screen, please.
Yeah, we can see your screen.
Okay, thanks. First of all, thanks a lot, INMEX-SMM, for allowing me to present our thoughts and our experience in Maritime 4.0. It was excellent to hear Girish, his perspective and what DNVGL is doing in digitalization. And we hope to hear more from Dr. Rahim also subsequently on the general trends across the industries where they are adopting Industry 4.0. I will be mainly speaking in detail on two specific digitalization tools and how to effectively implement those. Also, we saw today morning Dr. Malin Shankar mentioned in her address about the importance and emergence of digital twin and AR VR as a technology in the marine industry. She also mentioned that the main challenge for adoption of these twins is the cost and complexity. So our objective at Maritime VR has been to bridge this gap and make the technology easily available and at a cost-effective way. So we are at the dawn of Industry 4.0. The first few industrial revolutions were very long cycle of 100 years. Industry 4.0 ticked in within 50 years. And while on one hand, 4.0 talks about innovations in automation, production, and industrial processes, on the other hand, it enables autonomous decision making. It enhances asset monitoring by enabling connected networks and by making assets and data easily available to the stakeholders. So broad technologies for the Industry 4.0 are big data, robot, simulation, system integration, IoT, cybersecurity, cloud computing, additive manufacturing, and augmented reality. All these tools focus on greater productivity, better resource management, and also on more efficient decision making based on real and accessible information. Shipping companies are also exploring various different ways to leverage these new technologies to improve the efficiency and productivity of their investments. Now, some of these technologies, as we saw, are already implemented and are being used, like with the established IoT providers. Many ships data are now very well available onshore, and some of these technologies like autonomous vehicles, smart ports, new fuels are still coming up. One of the major goals of Maritime 4.0 is to develop innovative, digitally connected ships and to bring ships closer to the stakeholders for better and faster decision making. So digital transformation, of course, leads to significant cost savings. Although a lot of innovations in the maritime is driven by the compliance, we have seen the players who are adopting to technology to as a focus to operational to reduce operational expenses and to enhance operational efficiencies. So this is a KPMG report who mentioned about various different cost savings. So it can right digital tools can actually save from 10% to 20% on various different OPEX categories. So it is very important that investment in the right digitalization tool can be achieved so that we can achieve significant operational cost reduction, safer ships and cleaner environment. Ship owners are increasingly using 3D digital technologies and are looking at 3D models to see how they can enhance their own operations and efficiencies. Now, ships being far at sea pose inherent daily challenges operations, right? Like crew familiarization is being done using presentations, photos. Cargo planning is done using 2D drawings, photos. Technical reviews are also done using various printouts or 2D drawings which are available in PDF formats. Trainings are done using generic presentation or generic animation videos. Repair retrofit planning at the early stage, first stage, is also being done using 2D drawings and photos. So a lot of these challenges or these methodologies can be definitely enhanced using augmented reality and virtual reality, which is an important piece of technology for the Industry 4.0. We heard Mr. Girish also mentioned about the use of remote inspection by DNV and by other classes for remote surveys. So one such solution is the remote assist, which is a software solution which enables an onboard ship surveyor or a ship staff to video telecast whatever he is seeing to a person in the office, to a remote expert. And this could be a normal video and audio call. Along with that, it can also enable live annotations and recordings. So the the remote expert can actually annotate what he wants to explain to the site surveyor, and site surveyor will see that annotation live there itself, making the conversation much easier. The whole conversation can be recorded. The remote expert can also telecast or can also share the screen, show the PDFs, videos, various different the regulations or deviations to the person at site on his AR glass. Now, ships pose an inherent challenge of low bandwidth in the ports and in various locations. So in those cases, this solution can also enable seamless audio. You can stop the video and seamless audio. And in the audio mode also, you can share the snapshots and do the same discussions with respect to annotations, markings, planning out the routines or maintenance or troubleshooting. There's also a mode if there is no internet, the ship is at sea and there are inspections or troubleshooting to be done. So there are predefined steps which can be followed by the person. So even a person who is semi-expert can also do the inspections with a predefined checklist, and the checklist is supported with various different documents to explain the methodology, and all this can be recorded and automatic report can be generated on this by the cloud. So this brings a lot of benefits by making the show staff accessible. So it can be used by, as Girish said, used by the class societies. It is also used by the ship owners, ship managers, and the potential savings could be more than $40,000 if suppose a superintendent is visiting twice a ship and managing 4 ships, right? So and it can also save around more than 8 weeks of man days and enhance the operational efficiencies. In addition to reducing travel expense and reducing the resolution time, it will also help establishing central control and seamless communication, improves training effectiveness, and increases operational efficiency. So we saw remote assistant and inspection is one technological tool which can be useful for live connection to ship and can be used for inspection, troubleshoot, and maintenance. While then there is also a need for easy visualization and accessibility of ship info. Need not be the live, but the ship info should be available. So current methodology is a lot of ship data is available in the hard copies or in the PDF stored in various different folders, and then updates keep happening that not necessarily get reflected in the folders. So that is where the digital twin comes in. So earlier speakers spoke on the digital twin. The major challenge in the full-fledged, full-scale digital twin is it's very, very complex and very expensive to create. And it can be it's mostly done for the new ships. And in the ships also, it has not come up. We have seen some offshore companies like SBM creating the full-scale digital twin for the new FPSOs. So, and not just creation, the use of those digital twins is all use and maintenance of those digital twins is also very, very challenging. You need experts and you need high-end infrastructure to maintain that. So a lighter version of the digital twin could be a photorealistic digital twin. So the main difference between the full-scale digital and photorealistic digital twin is this is not a design model; it's a realistic photorealistic model, and it will have majority of equipment and other details which are required for day-to-day operations, but may not have the detail which is required for building the ship or for repair and retrofit of the ship. So what is photorealistic digital twin? So photorealistic digital twin is a 3D captured image of an asset with specific information of components, functions, maintained throughout the life cycle and easily accessible instantly. That is important. It is easily accessible and instantly. So via digital twin, you can walk around, you can see the ships, you can see the equipment data, you can see the drawings, you can download the training manuals. You can have all the equipments and important aspects tagged. You can also produce the technical information of those particular equipments. You can also have the manuals or a repair plan, repair histories, or the videos, training videos of specific equipments or of a specific system. You can also highlight some of the key aspects of the vessel, like mainsail line, or like let's say new system installed like ballast water system or scrubber system. You can also simulate escape routes, and these escape routes, these twins are specific to particular ship. So these are not generic escape routes. These will be escape routes specific to that particular ship, right? So that way the training becomes more and more efficient. There are various ways to navigate this the whole twin using floor plan views. You can also review the whole twin in a virtual reality mode where individuals can walk inside and explore the ship. Imagine a crew before joining the ship, going through the ship virtually within his office, and not necessarily also in the office from his own location. So this enhances the training to a different level. And again, you're not getting trained onto a generic ship or a generic model. You're getting trained to that particular ship which you are going to join. If the ship has a IoT data, right? So this can also integrate the IoT data from the ship. And while you're walking through the ships, walking through a pump, you can see what is the live data of the pump, what is RPM, flow rate, etc. And if the ship has a CCTV feed, that can also be integrated. So once you are walking through, you want to see for that particular CCTV what is going on in that location. You can also see that live. I'll quickly unshare and show a small demo. So this is one PD twin of a oil tanker. Okay, so we are currently in the engine room, so we can easily maneuver, move around to different locations. We are on the floor. You can see the equipment details. Like this is ballast number 2 ballast pump. What is the equipment details? You can also see the equipment, various different equipments. We can see the audio files, video files, or any kind of equipment data which you want to install. You can also see the live data from the ship, what is coming. So there's a live data coming from the ship. You can see, and these are all customizable, whatever data for what particular ship we want to see, we can see these. This is easy to navigate. Via floor plan, we can move to, let's say, navigation bridge. You see the beautiful ship, beautiful bridge here. You can walk around, you can see the respective consoles. You can add more details about the consoles for the training, for the simulations. You can go to main deck and move around, and so this is a very, very short demo, and this is something which can be implemented in very, very short time. So as people said, and as everybody believes, understand that digital twin is a complex thing. So this is a very easy process to create. So it's very easy to create, and then let's say for an engine room of a Suezmax carrier, we can create this into 6 to 7 hours. That's the capture time on the ship, right? And it's very cost effective. It's not like it costs tens of thousands of dollars. It's very cost effective. And once it is created, it is also very easy to access. Compared to the full-fledged digital twin, where you need expert, you need high-end hardware systems to be able to access that. This doesn't require any training. You can access on any devices, on your phone, on an iPad, on your desktop, or on a virtual reality glass, head-mounted gears, and it's also easy available online via the password protected dashboards. People can see based on the respective ships. The superintendent can see and log in anytime. The training companies can, the training department can give out the specific logins to the specific crew joining, and then they can access from anywhere on the ship. So there are immense benefits, immersive experience. We can conduct effective trainings, experience various places on the ship as if you are visiting in person, easy transition to the real type situations for new personnel and trainees. We can have in-depth engagement, this acts as a centralized visual data bank of your vessel with key information integrated into TIN. So this is not just a virtual visualization tool, but it has integrated all the data of the ship. So imagine all the equipment manuals, ship's drawings, the history of the repairs, any updates which happens onto the equipment, everything in the same place. We can familiarize the new joining crew, enhance the safe operations, and develop group-wide expertise. So PD twin enabled operations we call as efficient operations. It can help crew familiarization, cargo planning, technical review, training, repair, retrofit, planning, etc. The photorealistic digital twin saves time, efforts, cost incurred from continuously searching, coordinating, reproducing, validating the information required for that particular moment for making a critical decision. So these are the two different tools. This is part of Maritime VR platform, which is using AR, VR and enabling better decisions for the ship owners. So there are different companies in India, Indian Navy, and few shipyards are using our remote inspection tools. Photorealistic digital twin is being used by few ship owners in Singapore. Somebody is using in Saudi Arabia is using mainly for the crew training. There's a ship owner using for annual reporting of the ship status, and there are various different use cases for these. There are other solutions which I will not go in detail today. This 388 site, which is we have an Android app which can convert 2D drawing into 3D models in the site for during the retrofit and construction stages, and the collaborative VR design review. So designs which are being done in 3D model can be reviewed in a virtual reality platform, collaborative with people joining from multiple locations across the globe. So Maritime VR in short is a platform by Vedam Design. Vedam offer design solutions for marine, naval, offshore, dredging, gas, like ship design, detail design, engineering analysis, retrofit and conversion, supervision, and consulting services. We have done more than 1,200 projects, 2.0 million engineering hours, more than 250 customers. We have around 150 designers spread across 3 offices. That's it. With this, I'll thank you everybody, and if any questions, I can take it now or towards the end.
Thank you, Mr. Jain. We now move to the last session for this last presenter for this session, Dr. Abdul Rahim, Corporate Officer and Regional Manager, Class NK. Mr. Rahim has been with Class NK for 28 years, serving long stints in various roles in Tokyo, Singapore, London, and Mumbai prior to Dubai. He started his career with Cochin Shipyard building Panamax bulk carriers and the first series of double hull tankers. Dr. Rahim holds a bachelor's degree in naval architecture and shipbuilding from Cochin University of Science and Technology, and master's and doctoral degrees in ship structures from Hiroshima University. Over to you, Dr. Rahim.
Thank you, Padma, for the introduction. And let me just share this screen. Can you see the screen?
Yes, sir.
Just a minute. Now the presentation mode is on. Can you see it now?
Yeah.
Yes. Okay. Thank you very much. Following my two co-presenters, I will dive into two aspects of smart ship technologies. One is digitalization, the other one is autonomous ships. As you know, there are quite a number of smart ship technologies available, and some of them maybe, as my co-presenter mentioned, drones. Drones used for mainly for ship inspection from the classification viewpoint. And then there's a couple of remote survey technologies like glasses and other things. And then we have the digital twin, much talked about these days. That is to run simulations using real-time data and artificial intelligence. And then, of course, we have the autonomous ships and, of course, many other technologies. But today, I will concentrate on digitalization and autonomous ships. Yeah. There's challenges for digitalization. One, it's the fragmented approach, as we can see here, because the data capturing and transmission by software solutions are not standardized. So data comes in all formats. Secondly, the lack of harmonization. Again, I mean, this is what I was mentioning about the data capture. And finally, the lack of framework. That is, there are no rules or regulation for the data ownership and data distribution among stakeholders. So if you look at the current, say, typical ship, you have different data collection units, you have different data servers and different applications on board. So possibly the data is collected and sent to each application individually. And these ones are then transferred to exclusive short platforms. And from there, it is sent to stakeholders. So that means the same data is transferred again and again to the short platforms, and that's actually not at all coordinated. So what we are suggesting is a central shipboard data server based on an ISO standard, ISO 19847, and that consolidates all the data that requires to be transmitted outside, and it comes to a short-based repository. So it can be a ship data center, we call it, and from there it can go to the solution providers or data buyers, or whoever is required. So if I further explain a little more, this ship data center, we call it, that is the first maritime ship data center was established by Class & K about 6 years ago. What we did is we have centralized the data from ships to a short-based data center, and we standardized the data received from the ships, and then facilitate a big data platform to co-create new solutions. So if you look at the schematics, so this is the data center, as you can see here. And these are the inputs coming from different software platforms or wherever it is. So INMEX, it's a condition monitoring system, fleet monitoring system. But all this data, as I mentioned before, comes in all different formats, but the data converter converts them into a standard ISO format. And then it is sent into a database where other data, say for example, the related weather data, etc., is added. And the ship data center holds onto this database. And the users, say for example, shipping companies or shipyards or equipment makers, whoever who needs the data, can access it through application protocol interfaces to get the data from the ship data center to their respective servers. So when you say digitalization, say, as you can say, digital twin is a successful implementation of digitalization. And so digital twin, I'm not going much details into digital twins now. And what I want to explain is, say, for example, you have an asset model, it's a digital twin, and we have all the data from sensors, actuators, and everything. Then we have the data related to the design, building, and operation that is fed for analytics, and everything is finally analyzed, that is predicted, described, and prescribed the behavior of the asset, both physical and machine learning model. So that means intelligence is built on top of the data using analytics, physics, and algorithms or machine learning. Now, these are a couple of examples of digital twins. So it can be a component twin because it can just represent one rotor or a blade, or it can be an asset twin, or it can be a turbine or a motor, or it can be a system or unit twin. Say, for example, a ship itself can be a system digital twin, or we have the process twins where we are digitalizing the manufacturing processes. Now, let me example of a component twin, how it works. So for example, this is the main engine. Main engine is a component. So while running, say maybe you can detect wear and tear, maybe the next day, maybe in 1 week, maybe in 1 month. And because of this fault, if not proper action is not taken, the machine may stop. Then we start analyzing, and if it can be resolved, it can be resolved. Otherwise, it will lead to machinery breakdown. So using the digital twin, what you can do is you can run the whole simulation that the normal process that may take days or weeks or months in a few minutes. And then you get to know what is going to happen, and you can take corrective actions. So if I bring it into the real space, as you can see here, the digital space, the system gives warning. So that warning is replicated in the real space, and then you are taking the corrective action by analyzing the root cause and identifying the problem, identifying the solutions and implementing it. Thus, you are avoiding the machinery breakdown and the off-hire. That means the normal operation continues. And this digital twin, so for example, this is one software, we call it INMEX-SMM LCA. We jointly developed with Mitsui. So this is the digital twin of the main engine. It can predict if something is going wrong, maybe say within maybe next 24 hours or next 48 hours, the machine is going to break down or these things can malfunction. So then we can take corrective action and go. Another example, say for example, asset twin. In the real ship's bridge, say for example, there are so many equipments like radar, voice recorder, camera, EPs, VDR. And this can be brought in the digital space. So it can be a digital twin of the ship's bridge. And using the big open data platform, you can analyze it and send it back to the real space. So I'll just skip what is written there. So an example of this digital space is mentioned here. You know, the maritime software company NAPA and the manufacturer of voyage data recorders, IGDIS, and other equipments, Denelec, they have joined together to offer a complete end-to-end Internet of Things cloud solution for ship performance analysis and optimization. So this is the digital twin of the ship's bridge in the digital space. Now, I will show you another usage of it. So this is the real space, that is the actual design, the actual construction and actual operation of the ship and its machineries. So these data are sent into the big data platform, and from there we are sending the data to the digital space where you can do simulation, that is the real-time simulation, we can do that, and then fed back these solutions to the real space so that the results can be used for voyage optimization, maintenance, survey, everything. That is, it's actually based on the latest condition of the vessel, which we have analyzed and predicted in the digital space. Now let me go into autonomous ships. That is the second part of my presentation. As in a lot of technologies like sensing technology, AI, or Internet of Ships have made rapid progress. And as you know, globally, the R&D for autonomous ships are carried out. One of the main reasons is to improve safety by preventing human error and also to improve the working conditions. Because countries like in Europe or Japan, or for that matter, the labor is very expensive. So they want to cut down on the number of crew working on this. So for them, that is a motivation to bring autonomous ships. And quite a number of projects worldwide are ongoing in automation. And I want to introduce a couple of projects that is being done in Japan. And one group of projects is headed by the Ministry of Land, Infrastructure, Transport and Tourism in Japan. We call it the MLIT. So they have quite a number of projects running for ship automation. And another series is the project by Nippon Foundation. We call it the Meguri 2040 project. So I will tell you the meaning of 2040 in the next slide, in one of the subsequent slides. See now, looking at the target for autonomy. So on the deck side, the navigation side, we have the lookout function, the radio communications, the steering, and all those things can be automated. And for the port entry and departure related one, the preparation work, mooring, unmooring, anchoring, unanchoring, all those things can be done by automation. Then the hull related maintenance, patrol, cleaning, etc. can be done. And the cargo management, like loading plan, cargo status management, cargo handling preparation work, so on and so forth. And coming to the engine side, again, for navigation, the main engine operation can be automated. Then response to alarms, recording, so on and so forth. Then the port entry departure related works. Then the main engine load adjustment, lube oil adjustment during main engine slowdown, etc. So there's quite a number of tasks that can be automated, and that is the target of these projects. Now, if you look at the degree of autonomy, the IMO has defined it into 4 degrees. In degree 1, the ship with automated processes and decision support. And in degree 2, it's a remotely controlled ship with seafarers on board. And in degree 3, remotely controlled ship without seafarers on board. And the degree 4 is fully autonomous ship. Whereas in the Japanese Ministry of Land, Infrastructure, Transport and Tourism, they are currently considering 3 phases. The phase 1 is the ships utilizing Internet of Things technology. Then in phase 2, ships that support the crew by remote maneuvering from land or action proposing functions through artificial intelligence. But the final decision is made by the crew. And in the phase 3, it's a highly autonomous ships, which a system can make the final decision for some tasks in place of this crew. That means all the tasks are not automated, but most of the tasks are automated, but the key tasks has to be done by the crew. So now you look at the automated operation system. Now the concept that the system will gradually and partially replace the decision-making process that has been carried out by crew is common to major class societies. I think a number of class societies are working on the autonomous ships project, in different parts of the world. And if you look at the autonomous operation system, the information collection devices send in the information. And then the system analyzes the awareness of what condition currently is. Then it is making the decision and the action is taken so that the signals or whatever is into the actuators and other components. So here, in the case of case 1, the situation awareness is taken by the computer system and the decision and action by human. And in the case 2, decision and action taken by human, whereas the situation awareness can either be computer or human. But in the case 3, everything is done by a computer system. Now, one of the prime aspects of autonomous ships is safety. So ISO decides safety as no acceptable risk. So that means we have to eliminate the unacceptable risks. So in conventional ships, it is done by crew. And whereas in autonomous ships, it is done by the cooperation between system and crew. Then, if you look at the capability of the crew, it is defined in STCW. So in an autonomous ship, if the system is to partially replace the capability of the crew, then it is very interesting to know how the system achieves this capability. Now, coming to safety again, there can be two types. One is the intrinsically safe one, that is reducing or eliminating the cause of a machine's harm to humans and the environment. There is no interaction from external devices. And the second one is the functional safety, that is to ensure an acceptable level of safety by introducing functional devices. So, for example, in this interaction between the rail and road, the signals, they act as functional devices. Now, the safety is again, we have to be very clear about the normal condition and safety in case of emergency. That means you have to separately consider. So in normal condition, the minimum requirement you can define, because this is the certain requirements we can stipulate, and this must be satisfied for the normal condition. Whereas in an emergency condition, the situation is already below the predefined minimum requirements. That is the normal conditions. So it is important to not make the situation worse. So we have to be very careful to get back to the normal condition from an emergency condition without creating any problems. So this is the schematics. I will explain the relationship between the operation design domain. That is, this is the normal operation domain. Then this is the minimum risk condition in the normal condition. And this range, this green one, is the normal safe operation range. And if the system goes out of here, then there has to be some minimum risk maneuver with which we can get it back into the MRC in the normal condition range. So that means we call this fallback, and we need to take countermeasures to minimize the risks when the system malfunctions outside the normal range. Now, how to verify the safety equivalent to humans? Of course, that we are doing through risk assessment. And it is necessary to devise ways to carry out risk assessment effectively and efficiently. So we have to define basic elements for ensuring safety, and these are these elements, and all these the minimum requirements have to be met. So we are carrying out the risk assessment based on functional requirements specification of these basic elements. And here what I have shown is the front page of the guidelines for autonomous ships that we have Class K has issued last year. Now let me give you an example of a couple of pilot projects. So this pilot project, what I'm showing is the world's first maritime autonomous sulfur ship trial performed in accordance with the IMO's interim guidelines. This trial was carried out in 2019 by NYK. It is one of the Japanese major shipping company. They have used this 70,000 gross tonnage pure car and truck carrier named Iris Leader for this. They have navigated this vessel from Shinsha in China to Yokohama in Japan. And on the way, in two stretches, they have carried out the autonomous trials. The first trial lasted for 3 days between Yanagunijima Island and Ashizuri Island. And the second part, they carried out for 3 days between Nagoya and Yokohama. And this is the Meguri 2040 project and other related projects put in one phase. The Japanese government is very much keen to attain certain targets by 2040. And in the timeline, this is the mass trials that I have just mentioned. And another remote navigation test was carried out in 2020. And there is another ongoing project, DFDAS, and this is covered by these red lines. That is crewless maritime autonomous ship demonstration trial will be carried out based on this one. And the ultimate aim currently is to implement this on small new building vessels and to expand to existing domestic coastal vessels. So the target is by 2040, 50% of the domestic coastal vessels in Japan will be going through crewless automation. There'll be fully automated ships without any crew plying by 2040. That's about 50% or something. So this is the target. It's gradually going up. In this respect, I will show you a couple of pilot projects. This project was carried out just last week. It's a passenger ship, and it was carried out by Marubeni, Triangle, Mitsui, and the city of Yokosuka, where this passenger ship is flying. And for this passenger boat, they have carried out fully autonomous ship operation, including unberthing, navigation, avoiding collisions, and berthing. And this was carried out between the New Mikasa Pier and Sarushima Island in Yokosuka City. It's only a few kilometers, but they have carried out the autonomous test that the vessel could go all by itself without any external help from one place to the other. The second project I want to show you was carried out just day before yesterday, that is 2 days ago. This was done jointly with Mitsubishi Shipbuilding and Shin Nihon Kai Ferry, which owned this ferry. It's a 222-meter long passenger ferry, and the systems tested in these ones includes the autonomous port berthing and unberthing, high-speed navigation system, then sensor imaging system that detect other ships even in darkness, remote engine monitoring system, cyber security system, etc. And this run was done between Shimonji in Kitakyushu to Yonada in Shikoku Island. It's about 240 kilometers, and the 7 hours sailing time at the maximum speed of 26 knots. And this is the ship Sarayu, which was part of this project. On this ship, they have carried out the test. This is a part of the Meguri 2040 project. And of course, it is mainly funded by the Nippon Foundation. So with this, I would like to conclude my presentation. Now I will stop sharing and over to you, Padma.
Yeah. Thank you very much, Dr. Rahim. And we have a set of questions which I would like Mr. Santosh Patil to take over and ask the panelists. Over to you, Mr. Patil.
Thank you, Padma. Looking at the questions, there's one question which I think is addressed to Mr. Akshay regarding the digital twin software. While it seems useful to training institutes and departments, what are the benefits can a technical superintendent gain from such a solution? Can you elaborate on this, Akshay?
Sure. So there are tremendous benefits from the technical superintendent or for any technical person to evaluate. So currently any issues on board. So to evaluate the challenges, what is happening, the standard way is to go to the hard copy drawings, which are also just as schematics, and also or get the photos of the location that or if they suppose they need to replace a pump, right? So to simulate the dismantling route, it becomes a very challenging. Just looking at the 2D drawings, we need to get from the chief engineers a lot of photos and assess. Right. So now with the PD twin in their hand, they can quickly assess that how they can dismantle a pump, where it can take it, and what are the obstructions around that. So this is one example. But other example could also be like one of the ship owner is using for the dry docking management. So normal traditional way of dry docking management is the specs are written in the office. Before that, superintendent would have made a visit onto the ship to gather the challenges or the problems, or the chief engineer submits the problems in the pump. So what this particular ship manager has been facing the challenges, they say the pump is damaged, right? So now pump has to, the spare parts have to be ordered, but in the repository they had very old pump which was provided in the new building stage, right? And by looking at it itself, people could see this is not that brand pump, it's a totally different pump, right? Than the manual what you have. But while going through PD twin, you can quickly recognize, and in those twins we capture the name tags on all of the equipments. So you can quickly map it that the equipment is from the same make and same OEM, or it is a different equipment which is installed and the data you have is different. And then all those data is also in the same twin itself. So if you want to download the manuals, the repair, the spare parts list, and the repair history, everything you can in the one place download. So there's tremendous advantage for the technical superintendent and the technical team to use.
Thank you, Akshay.
If I may add, Akshay was talking about the digital twin that he was mentioning. And digital twin, as I mentioned before, there can be different types of digital twins. And some of the digital twins that I have mentioned is of tremendous help to the superintendents. The biggest advantage is they don't have to go out of their table to monitor the ship. The engine room or whatever functions, everything they can visualize on their computer in real-time basis. So that is the biggest advantage of this digital twin.
Thank you, Dr. Rahim. The next question is, and I think Mr. Girish could probably take it. Will the safe manning be affected with autonomy in deck and engine controls?
Yeah. So, as we progress, I would say that the number of people required on board will reduce. But having said that, it is expected that, there will be more amount of shore opportunities, because I do not expect, as Dr. Abdul also showed in his presentation, it's going to be a progressive change. It's not going to become like fully autonomous within the next 5 years or so. It's going to be still a lot of assistance coming from remote to the ship staff. So there will be lesser number of people required, but more, different opportunities coming ashore.
So in this respect, I just want to add in a couple of projects that is ongoing in Japan. So for example, it's a tugboat. The initial number of crew was about 8. That for that couple of tugboats, now it is running with just 2, one chief engineer and one captain. That's it. So they can reduce the number of crew tremendously, but the safe manning is an IMO specified one. So for international voyage, there has to be an agreement. So currently it can be done within a country in the coastal waters, because those countries can define the safe manning level. So for international things, it's a long way to go.
Thank you, Dr. Rahim. I think we are quite behind schedule, so I'll just quickly wrap up. I would like to sincerely thank Mr. T.S. Girish, Dr. Abdul Rahim, and Mr. Akshay for their informative presentations and their insights. Our sincere thanks are also there to the participants of this session, and we all look forward to see you in the next session.